Alrighty, you guys, 6.1a lesson. We're going to kind of do this lesson. I'm going to be jumping around a little bit and doing this in a couple of different parts. The first part will be just as normal. And then the second part, I'm going to bring up a program called Desmos, which if we were in class physically, that's what we would be working on together going through this lesson. Okay, so looking at this diagram, okay, and relating back to our vocabulary, okay, I want to make sure that everybody understands there are many answers for numbers 1, 2, 3, 4, 5, 6. Okay. Note there are many answers for numbers 1 through 6. Okay, I'm just going to come up with one for each. Okay, a scalene obtuse triangle. A scalene, that means all side lengths are different. Obtuse, meaning one of the angles is more than 90. I think I found one right here. Okay, what about this guy right here? Triangle RQO or ORQ. Triangle RQO. That's one example. That's all I needed to find. Okay. Isosceles right. Isosceles right. Looks like OP and PQ are the same, and it looks like this is a right angle. So OPQ is 1. Triangle OPQ. Isosceles obtuse triangle. How about this guy up here? MNO. MNO. Okay, isosceles meaning this and this are equal, and N is obtuse. That angle N is obtuse. Triangle MNO. A parallelogram. Okay, the definition of parallelogram is two pairs of parallel sides. Two pairs of parallel sides, a four-sided figure. Okay, usually a parallelogram, you kind of sit on a corner and it kind of squishes it over. Okay, so it's important to understand a rectangle is a parallelogram. Okay, I'm looking at, I just lost it. Let's look at this guy right here maybe. KQHI, this guy right here. These look to be the same lengths. These look to be the same lengths, okay? So to be a parallelogram, we have two pairs of parallel lines where opposite sides are equal in length, okay? All right, so parallelogram, we said KQHI. You guys, very important to point out, you cannot label this as KQIH. It has to flow around like you're tracing that black line. Okay, it could also be QHIK or IHQK. Doesn't matter if you go clockwise or counterclockwise, okay, but you need to flow around it. Okay, a rectangle that is not a square. Does everybody understand a square is a rectangle? Okay, so we're looking for a rectangle that is not a square. How about this big giant AJGE? Kind of looks like this is smaller than this, so that's going to be a rectangle. Okay, so rectangle AJGE. Trapezoid. Trapezoid is a four-sided figure that has exactly one pair of parallel sides. Okay, so I see one right here. MOPK. MO is parallel to KP. Those are parallel. Okay, and then the other two sides are connecting those parallel lines. Okay, so trapezoid, M-O-P-K. Okay, and again, there are many. Those were just one examples of each. Okay, these words right here, not drawn to scale. These are super, super important. Okay, these three sides are labeled with this one mark saying that they're equal in length, even though if they don't look like they are. For example, over here, kind of looks like this might be a little smaller than this, but guess what? Because they're labeled with the one mark, they are equal. So when you say not drawn to scale, they might not look like it, but it's whatever they're labeled to be. Okay, so if we're going to classify this by sides, remember by sides, that was scalene, equilateral, and isosceles. Okay, and please remember an equilateral triangle is an isosceles triangle, but an isosceles triangle is not an equilateral triangle. Okay, and then angle. Angle is going to be right, obtuse, and acute. Okay, so sides, these are all equal, so this is an equilateral, and this is definitely an acute, no angles bigger than 90. This guy, two sides are marked the same, so this is going to be isosceles, and we're looking at one obtuse angle. Okay, can a triangle have more than one obtuse angle? Challenge question. Hopefully you're thinking no, because would it even form? If you had one bigger than 90, okay, and then another one bigger than 90, would those sides ever connect? No. All right, this guy down here, number 9. Nothing is marked, so it must be scalene. And we've got one angle marked, and that little box means that it's right. So this is a scalene right triangle. This guy, two sides are marked the same, so isosceles, and all of the angles are acute. Okay, so again, this vocab, you've got to have this vocab down by now. All right, let's do some true-false questions. All right, it says true or false. Explain your reasoning if it's false. Explain why it's false. All right, an isosceles triangle can also be a right triangle. True. Okay, and I'll put a little bit of an explanation on every one of them in case you need to understand it better. True could be 45, 45, 90. Okay, so it's isosceles because you know two angles are the same. Guess what? Two sides are the same then. Okay, and it's right because of that 90-degree angle. Okay, if two angles in a triangle are 40 degrees and 35 degrees, the triangle must be acute. Okay, be careful here. We've talked about you need 180 total degrees in a triangle, and if this adds to 75, what's that third measure? 105. Okay, it's not going to be an acute, so this is false, since the third angle would be 105 degrees, which is obtuse. An obtuse triangle can have multiple obtuse angles. False. We just said that that cannot happen. Okay, 3 angles must add to 180 degrees if two of them are more than 90. Would this work? Am I off? Nope, I thought I was off the paper. Would this work? All right, an acute triangle has three sides that are all different lengths. Okay, that's false. Okay, couldn't we have an acute equilateral triangle? Couldn't we have an acute equilateral? Okay, and then 15, a scalene triangle can be an acute triangle as well. That's a true. Okay, sides can all be different measures, and angles can all be smaller than 90 degrees. Okay, that definitely works. Okay, keyword is can. It doesn't say has to be. Okay. All right, number 16, a scalene triangle has three angles less than 90 degrees. False. Could be. A scalene obtuse triangle. Okay, there's some true falses. All right, we are going to skip to number 23. And then the second part that we're going to do with that other program, we'll come back and kind of fill in what we're skipping. Skipping to 23. All right, we need our tools again for this one. It says, given the following criteria, construct a triangle. Draw and label triangle ABC with AB being 2 centimeters, BC being 3 centimeters, and CA being 4 centimeters. Okay, very important when you are constructing these triangles to be using a pencil because you're going to have to erase and retry. Okay, so I'm going to start with, okay, do you see how my 0 is kind of off? I can't mark it. I'm going to mark 1, and if I want 4 centimeters, aren't I going to 5? Okay, I just did 4 centimeters. So that's CA. Okay, now I need B up here somewhere so that BC is 3 and AB is 2. So I need to try like something there-ish. Okay, let's see if that works. So again, I'm going to start at 1, and if I need 3, I'm going to mark 4, if that makes sense. That's 3 centimeters. Okay, and then I need to make sure that this is 2. So it would be 2 to 3, and it's not. Okay, so I need to go up a little bit. So I'm just kind of playing around with where I'm putting that 4. Let me put it right here. Remember, 1 to 4 is 3 centimeters. And then this has to be 2. So this needs to be 1 to 3. Ooh, that's too many dots here. Let me erase these and see if that 1 works. Okay, this needs to be 3. And it is. And then this needs to be 2. And it's a little bit more. So that has to come down a pinch. Just a pinch. I'd say right about there. Okay, so that's 3 centimeters. And then there's 2 centimeters. Okay, so hopefully you just saw, oops, I gotta draw the line, don't I? hopefully you just saw that I had to play around. You can see all those little dots there that I erased. Okay, I put my longest line down and then I played around with where I need to put a dot to make this guy, this is B, to make this guy CB was 3 centimeters or BC, and then AB was 2 centimeters. Okay, this guy, draw and label ABC with measure of CAB 40 degrees, CA is 5 units, and BA is 6 units. All right, so I'm going to go ahead and put down my 6 units. The word units, we can be in centimeters, we can be in inches, we can be in feet, okay, we can be in miles. So we just need to stay consistent. Okay, so I'm going to use centimeters. And again, I'm going to go 1 to 7, and that measures 6 centimeters. Okay, so that's BA. 6 units, 6 centimeters, same thing. All right, now CAB, angle CAB needs to be 40. So A, this needs to be 40 degrees. That's my next step, 40 degrees. So I line up my protractor and I'm gonna mark 40. 40 is right there. Okay, so I'm gonna draw just a long line through that point. I didn't measure anything yet. I just drew a long line through it. But I did measure this to be 40 degrees. Okay, now I can come in and do, this is going to be C up here somewhere, and CA has to be 5 units. Okay, so if I do 1 to 6, that's 5 centimeters, and this is C. And then let me join these two, and then I have to just lastly measure them and make sure that that gets me. BC needed to be, oh, it didn't tell me. It just told me that I needed 6 centimeters here, 5 centimeters here, and this needed to be 40 degrees. So I'm done. I don't need to erase my extra marks. You can leave them on there. All right. Copying, duplicating. Copying using a ruler and a protractor. Label the sides and the lengths in centimeters to the nearest tenth, and angle measures to the nearest degree. And then we're not going to do the inequality because we've skipped that. And then we're going to classify it based on its sides and angles. Okay, so we're basically just duplicating this thing. So notice, well, I'll start at 0 since I'm just measuring. This is 5. 5.0. It said to do it to the nearest tenth. Let me actually do it on the outside. 5.0 centimeters. Ooh, another 5.0. 5.0 centimeters. $7.1. You try to read like to the middle of the dots. 7.1 centimeters. Okay, now for the angles. Okay, this is a straight up 90. This is a straight up 90. This one, 45. What do you think this one has to be then? Hopefully you're thinking 45. 45 right there. All right, so I've got all my measurements. Now I'm going to duplicate. So I am going to just draw a straight line. I didn't do any measuring. Okay, let's label right here B, and I need to measure 5 centimeters till I get to C. Okay, so if I start at 0, I'm going to mark this at 5. 5.0 centimeters, and this is labeled C. I need a 90-degree angle right here. Don't eyeball it, you're using your tools. 90 degrees, I need to go through that line right there. Okay, I don't know how long, I'm just going to make it long enough. So I'm not measuring anything, I'm just drawing a straight line. Okay, I just did 90 degrees. I need to measure 5 centimeters right here. Oops, broke my lead here. Centimeters, and this is A. Okay, and then I just need to connect these two. And I need to make sure that that distance is 7.1. Okay, and I'm a human, and I may be off a little bit, but whoops, not there. But it better be darn close. And it is 7.1. Okay, and the last things I need to measure are these two angles. They better be 45 degrees or very similar. Pretty much. I'm about 46, 40, 45 and a half-ish. Oh, goodness. 45, 46, somewhere in there. It said round to the nearest degree. Okay, and then I've got one more to measure here. Make sure it's, yep, 45. It's right between 45 and 46, so I'm rounding to the nearest. Okay, take a look at those two triangles. They are exactly as a human can duplicate. Okay, let's go to the next. Oh, we need to classify these. On the next page, it says to do the triangle inequality theorem. We'll come back and do that after we do the second part of this, but this is an isosceles right. Isosceles. Oh, I spelled it right. Isosceles right triangle. All right, we're going to do the same thing. Copy and label this guy. We're going to skip B and we'll answer C. We'll come back to B after we do part 2. All right, measuring 4.1. Remember it said to the nearest tenth on the side lengths. About 4.1 again. $7.1. Okay, I'm going to need something to elongate my side here. 30 degrees, not 150. It's acute. 30 degrees. Let's do this guy. That looks like to be also 30 degrees. Yeah, 30 degrees there also. And this obtuse one, let's see what that is. 120. Remember, we're taking the obtuse, not 60. We're taking the big one. All right, so that's what we're duplicating. So we're going to start with, I better make that a little longer. Start with just a segment here. Okay, we want 4.1 centimeters here. .1, and this is going to be labeled C. We want 120 degrees at C. That's next. Okay, we don't know where to put the other 4.1 because we don't know if it's here, here. Okay, we don't know what angle, so we need to do the angle next. So 120. 120 is right here. Okay, I'm just making a long line. I'm not measuring the 4.1 yet. I'm just making a long line. So now I'm going to go in and do the 4.1. Okay, this was 120. Oh, I just broke my pencil again, I think. Yeah. Okay, so this is going to be 4.1 right to here. And this is going to be labeled A. And then I'm just going to connect these last two to form that side. And then I need to measure this to make sure it's 7.1 or something very close, which it is. And then I need to measure both these angles and make sure that they're 30 or something very close. That one is to the nearest degree, 30. And then this guy, same thing, to the nearest degree, 30. All right, so if you look at my two triangles, this is a duplicate as good as I can as a human of this one. Okay, we're skipping part B, triangle inequality theorem statement. We'll come back to that after we do the other part. Classify the triangles based on its sides and angles. Well, we've got an obtuse angle and we've got two sides that are the same. So I hope that you see that this is isosceles obtuse. All right, that concludes part 1 of this lesson. Okay, and I will be back to put in the part 2 of this lesson and then come back to these couple of B problems. Thanks, guys.